The first sign was a single flight, a regional jet over the Atlantic, its pilot requesting a holding pattern because the onboard clock said they were 10 minutes ahead of air traffic control.
Center, repeat current time again. We've got a 10-minute mismatch up here.
Then Frankfurt called London, then Tokyo called New York, then Sydney called everyone. At 14:23 UTC, the Global Time Synchronization Network began reporting something impossible. This was the invisible pulse that coordinates every computer, every satellite, every financial trade, every power grid. Atomic clocks in separate countries, on separate continents, hardened against interference and cross-checked against each other for decades, started showing the same discrepancy. They agreed with each other, they disagreed with reality. By 1425, the first automated systems started shutting down because their internal safety logic concluded they could not trust the world outside them. At 1428 UTC, a trader in Chicago watched his screen freeze. His algorithms were programmed to halt trading if the timestamp from the global positioning system drifted by more than a millisecond. They recorded a drift of 14 minutes and 21 seconds. The exchange went dark. In a hospital in Bangalore, an MRI machine refused to start its scan. The internal clock, synced to a national time standard, reported the time as 14:42. A nurse checked her phone. It said 14:28. She assumed the machine needed a reboot. At the European Space Operations Center in Germany, a young engineer noticed something else. The telemetry from a GPS satellite showed a timing solution that made no sense. The satellite thought it was in a different position, not by meters, but by thousands of kilometers. It was as if the spacecraft had momentarily existed in a different relationship to the ground.
Either the clock is wrong, or orbit just changed.
Then the calls started coming in from the Deep Space Network. The signal from the Voyager probes, still transmitting from beyond the heliopause, showed a sudden, unexplained frequency shift. Not a Doppler shift from movement. A shift that looked like the time stretching predicted by general relativity. Except there was no gravitational event to cause it.
That isn't motion, something bent the signal.
By 1435, the public narrative had solidified. A software update, a cascading failure in network time protocol. Something human, something fixable. Engineers on every continent were told to find the bug. They couldn't find a bug because there wasn't one. The first person to suspect the scale of it was a researcher at the Apache Point Observatory in New Mexico. Her work involved lunar laser ranging, firing powerful lasers at reflectors left on the moon by Apollo astronauts, and measuring how long the light took to return. It was the most precise measurement of the Earth-Moon distance ever devised. When she checked the data from 1423 UTC, she found something that made her run the calibration tests 3 times.
The moon doesn't just move closer.
For approximately 14 minutes, the round-trip travel time for the laser pulses had shortened. Not by much, a few microseconds. But in a system that measures millimeters of change, microseconds were catastrophic. She called a colleague at the Goddard Space Flight Center. He had just finished reviewing data from the Lunar Reconnaissance Orbiter. The orbiter's clock, independent from Earth's ground systems, showed the same timing anomaly. But more troubling, its star trackers, used for orientation, had briefly lost lock. For 14 minutes, the spacecraft could not find familiar constellations because the positions of the stars relative to the spacecraft did not match the onboard ephemeris.
Listen, we didn't just lose lock. The stars were in the wrong places.
At ground control centers, that kind of language was useless. They needed root causes. They needed software patches. They needed to explain to airlines why 100 flights had reported impossible position conflicts because their transponders were reporting positions from 14 minutes in the future or the past.
Current UTC time is 14:32.
But the lunar data sat in a separate category. It was physical, it was measurable, and it had no human explanation. 3 days later, when the immediate crisis had passed and the world had accepted the software glitch explanation, a physicist at the Super Kamiokande neutrino detector in Japan pulled a different kind of data. Neutrinos are nearly massless particles that pass through ordinary matter like light through glass. They almost never interact with anything. That's why what happened next mattered. At 14:23 UTC, the detector recorded a burst. 23 neutrinos in 14 minutes. It should have seen only a handful all day. The physicist checked with the other major detectors. IceCube in Antarctica, the Sudbury Neutrino Observatory in Canada. All of them showed the same burst, same time window, same directional signature. The direction pointed to nothing, empty space, a patch of sky between constellations.
There's nothing there.
With no known gamma ray source, no supernova remnant, no active galactic nucleus, just void. The physicist checked the coordinates twice. When the data was shared with the team analyzing the lunar ranging anomaly, a pattern emerged. Every anomaly fit the same 14-minute envelope. It suggested something passing through the Earth-Moon system.
Let's be careful with the word passed through.
The question put to the room was simple. What kind of physical phenomenon could cause atomic clocks to drift, neutrino detectors to trigger, and spacecraft navigation to fail simultaneously? The answer that emerged was not a conclusion. It was a category of possibility. The solar system is not empty. It moves through the galaxy at 220 kilometers per second. It passes through interstellar medium, through cosmic rays, through the magnetic fields of other stars. But it had never before passed through something that left a measurable imprint on time. A small team was assembled to answer one question. What happened to Earth during those 14 minutes? They compiled every data source they could access. Seismic stations had recorded nothing. Barometric pressure was stable. Magnetic observatories showed a minor disturbance, but within normal ranges for solar activity. Only systems that depended on exact time or exact position had failed. That list was longer than anyone had realized. The power grid in Eastern Europe had experienced a transient imbalance. Not enough to cause a blackout, but enough that automated safety systems had disconnected several substations for exactly 14 minutes before reconnecting. The log showed the disconnections happened at different times, but the duration was identical. Air traffic control recordings captured pilots asking the same question in a dozen languages. Confirm current time. Controllers gave the same answer.
UTC synced to atomic clocks.
But the pilots, looking at their own instruments, heard something that didn't match what they saw. In a lab at the National Institute of Standards and Technology, a cesium fountain clock, one of the most accurate timekeepers ever built, had recorded a frequency shift during those 14 minutes. The cesium atoms had oscillated at a different rate. The timekeeping researcher looked at the readout again and said,
"That can't be. The clock didn't drift. The time had."
The team didn't know what to call it, a bubble, a wave, a fold, but the measurement suggested something worse. For 14 minutes, the fundamental constants governing time and distance were altered. The report was never published. It was filed, encrypted, and stored in multiple locations with instructions to revisit the data if the phenomenon repeated. Publicly, the event was written off as a complex systems failure. The airlines updated their software. The stock exchanges implemented new timestamp redundancies. The hospitals checked their backups. But the people who had seen the full data could not unsee it. What they had documented was evidence that the Earth was not isolated. The solar system was moving through a galaxy that contained structures, phenomena, artifacts, residues, capable of interacting with the physics that made human civilization possible. If it happened once, it could happen again. And if it did, it would interfere with reality itself. One of the physicists, in a private conversation that was later leaked, put it this way.
We spent decades listening for radio signals from aliens. Maybe that was the wrong idea. Maybe the first contact was what happened to time.
The lunar ranging data was quietly recalibrated. The neutrino detectors added a new search parameter, and every atomic clock on Earth continued ticking, second by second, measuring a flow of time that no longer felt quite as reliable as it had before. The clocks work now. The satellites know where they are. The networks trust each other again. But the solar system is still moving, 220 kilometers every second, toward the region where this happened. And if it's still out there, this may have only been the first contact.